Hi, here are the answers to the quiz questions on fluids. Number one, the dimensions of this plastic block are given as 2 centimeter times 3 centimeter times 4 centimeter, and its mass is given. You have to find its density. Now, density is mass divided by volume, and volume of this block is, of course, the product of length, width, and height. And that gives 24 centimeter cube. And now divide the mass by the volume to get 1.25 gram per centimeter cube. And the second question, the person has a weight of 900 newtons standing on snowshoes. Each snowshoe has an area 2500 centimeters squared. So to find the total area, you got to multiply this with 2 and divide the force by the area. But the area has to be changed into meters squared. So pressure is force divided by area. Force is 900 newtons. The area is 2500 times 2 times 10 to the negative 4 to change it into meters squared. And this gives 1800 Newton per meter squared as the pressure. A circular window of 30 centimeter diameter in a submarine can withstand a maximum force, and you have to find the maximum depth in a lake to which the submarine can go without damaging the window. Here pressure is H rho G and also given by force by area, so put them both equal to each other. H rho G is equal to F by A. Make H the subject. Force is given, so, and the area is pi r squared. That's the given force divided by pi times 15 centimeter is the radius, so 0.15 meter. Density is 1025. Here it's 1000, because it's fresh water, not 1025. It is in fresh water. Okay, so you get 751 meter. Here in the next one, 500 newtons of weight sits on the small piston of a hydraulic machine, and the area of that small piston is 2 centimeters squared. Large piston has 40 centimeters squared. How much weight can the large piston support? Okay, F in by A in is equal to F out by A out, because the pressures on both sides should be equal. Why? Since a liquid transmits pressure equally in all directions. Pascal's principle. Therefore, make F out the subject. Substitute. That's A out. A in is 2 centimeters squared, and the input force is 500 Newton. And that gives 10,000 newtons. Block of metal weighs 40 newtons in air and 30 newtons in water. What is the buoyant force? Buoyant force is just the loss of weight in water. Okay, so the loss of weight here should be 40 minus 30, which is 10 newtons. Because the reason why it seems to have lost weight is because of the buoyant force. Therefore, buoyant force is always equal to loss of weight in water or in a liquid. Okay, number 6. 4 kilogram cylinder, solid iron, is supported by a string while submerged in water. What is the tension in the string? Okay, that is the cylinder. Forces, weight acting vertically down, tension in the string up, and buoyant force also up. So the total upward force is T plus Fb is equal to mg because it is in equilibrium. So make T the subject, you get mg minus Fb. Mass is 4 kilograms. G is 9.8 minus, to find the buoyant force, it's volume times density of the fluid times G. But the volume of the fluid in this case is the same as the volume of the iron cylinder. Okay, and that is why to find the volume of the iron cylinder, just divided its mass by its density. That will give the volume of the iron or the solid, which is the same as the volume of water displaced. So that is 4 kilograms divided by the density is 7860 in kilogram per meter cube. Density of water is 1000. Gives 4.99 newtons. So when you put that there, get the tension in the string as 34.2 newtons. Number 7, a container of water is placed on a scale and the scale reads 120 gram. Now look at that. A 10 gram piece of copper, specific gravity 8.9, is suspended from a thread and lowered into the water, not touching the bottom of the container. What will the scale read? Now, surely the scale is not going to read 140 grams. So what's going to happen is, when the buoyant force pushes up on the copper, as a reaction, there's going to be a force acting down, which is going to add on to the scale reading. So all we have to do is find the buoyant force and add it to 120 grams. Now to find the buoyant force, you got to find the volume of copper first, which is its mass divided by its density. It's in gram and centimeter cube, so get is 2.25 centimeter cube. Therefore the mass of copper, the mass of water displaced. The mass of water displaced will be the volume of water displaced, which is the same, 2.25, times the density of water, which is 1. So that gives 2.25 gram, but 2.2 gram when you consider the significant figures. Therefore, the buoyant force is 2 grams. Okay, approximately 2 grams, and the reaction will be 2 grams down. And hence, the scale is going to read 120 plus 2, which is 122.2 gram to be perfect. A solid object floats in water with 3/4 of its volume beneath the surface. What is the object's density? This may look like a very difficult question, but just consider that the volume of the solid is V meter cube. Therefore, the volume submerged is 3/4 of V. That will be the volume of liquid displaced. And since it says it floats, the mass of the floating object should be equal to the mass of fluid displaced. Okay, let the volume of the solid be V meter cube. Therefore, the volume of water displaced is 3 by 4, 3/4 of that volume. And mass of the floating object would be its volume times the density. So volume times the density of the solid. But by flotation, mass of the floating object is mass of fluid displaced. So now we understand that this is the mass of the object multiplying its volume with its density. That should be equal to the mass of fluid displaced. Now the volume of fluid displaced is only 3 by 4V because only that part is underwater. And that gives 3 by 4 times 1000, which is 750 kilogram per meter cube. 8. Surface tension is given. How high will water rise? Okay, height is given by 2 times surface tension cos theta by r rho g. The theta here is the angle of contact, which is 0 degrees. Radius is half of 1.2, which is 0.6 times 10 to the negative 3 in meters. And the density of water is 10 to the 3. So on calculation you get 2.5 centimeter. This polar bear of mass 200 grams stands on an ice floe 100 centimeters thick like that. What's the minimum area of the floe that will just support the bear in salt water? Mass of the ice floe is its volume times density. Volume is area times thickness. So density is 980. And so when the bear is on top of that, the total mass would be the mass of the ice floe plus that of the bear. So the total mass of the floating object is equal to mass of fluid displaced. That is the volume of fluid displaced times the density. So on rearranging and collecting the terms for A together, we get 50 times A is 200, so A is 200 by 50, which is 4.0 meter squared. Thank you, and just use this and prepare for the exam.